Welcome. Just math, y'all. Here we are again today. Today we are going to do our special cases. So let's look at where we are. All right, so these are the 4 types of factoring that you're supposed to learn. The first one's GCF, second one's grouping, third one's trinomial. And last but not least is the special cases. We've got 2 special cases. We want to try to knock those out. These are formula based, and so you will need to memorize the formulas or have them in front of you. You can use the formulas, but it's pretty easy to memorize them. If you're trying to make sense of these, that's overthinking it. So don't overthink it. Try to, watch the formulas and do it. And then the last thing we're going to do, we're not going to do it on this video, but we're going to do this solving equations 5-5 on another video in a little while. And we'll be done with chapter 5. So next week, get ready. Okay? All right, so today we're going to do special cases. All right, so now special cases has to do with some powers, and they also have to do with 2 terms. So here's a reference sheet that I have given you that you should get. If you don't have it, you need to get it. It is on your document sharing or what place where you upload your test. There's also a thing in there that has perfect powers. So the place where you upload your test, you should see a document that says perfect powers, and that's this document right here. Okay, so 2 terms, special cases number 1. We've got 2 different ones. Now the thing about special cases is that they both problems have 2 terms. The first one is called a difference of squares, and here's what we got right here. This is the pattern. The first line, the a squared minus c squared, that's the problem, and then the answer is a minus c times a plus c. And this is called a difference of squares. Now this term squares, this is where you want to look at your list. Okay? And the term difference means subtract. So this is what this is called, a difference of squares. And I've got 6 examples I want to show you. So let's go through them very quickly. Okay, so now you're kind of already in the habit of putting an x and an x here for the x squared. That's right. Okay, and x to the second is a square. That's what we call a square. Some of you call it x squared. Okay, but so are all these other even powers. These are all considered perfect squares. Now, the reason why it's called square is because of geometric shape called a square. So if this is, we'll just do 9 for example. 9 is a perfect square. Okay, if I have 3 here and I have a square made with 3, that's not a very good square. Then if I look, that's 9. 3 times 3 is 9. 3 to the second power is 9. And so we call the second power a square. All right, so difference of squares. That was a freebie. All right, so you'll notice the A and the A, but then 25, well, that's the same as 5 to the second. And so we're going to have a minus 5 and a plus 5. And that's all there is to it. All there is to it. Let's do the next one. So 4 is on our list. Let me show you 4. 4 is on our list. Can't write on it, but it's on our list. Okay. And 4 is 2 to the second. We have n to the second, and this is 3 to the second, or squared. And so drop the baby 2's. 2n minus 3, 2n plus 3. Okay, that's it, and that's your answer. That's your answer. But we didn't do anything. I know. It's pattern recognition. Okay. This 36, 6 to the second, n to the second, 7 to the second, m to the second. Okay, now drop the little 2's. 6 and 6, n and n, 7 and 7, m and m, minus, plus. It's a different way of writing it. That's it. Okay. All right, next one. Ooh, 5's not on our list. Let's go look. Do you see 5 on our perfect square list? I see 5 to the second power is 25. Yeah, 5's not on my list. 5 is not a perfect square. 20 is not a perfect square. So, oh, what about GCF? I can do a GCF. Okay, well, let's do a GCF of 5. Let's do that. Okay, all right, am I done? No, 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 no. Now look. Now look. This is special. This is special. We've got squares. We've got squares. Okay. Got x, and that's a 2 to the second, isn't it? So x minus 2 and x plus 2. This is weird. I can't do this. Yes, you can. Let's really multiply this out and see what we get. Okay. This is where the meaning comes in. All right. I'm going to take this x and multiply by both of those. X to the second plus 5x. All right. Round 2. And we'll take the negative 5 and multiply it by both of those. I'm going to get a negative 5x and a negative 25. All right, combine my like terms, and I get 0. Gone. There you go. That's x squared minus 25. All right, let's keep moving. X squared plus 16. Well, is that x minus 4x plus 4? No. This one, oh, that's not the right color. This one's prime. It's because I can't even see it anymore. It's prime. X squared plus 16. Let me erase that because you can't see it. Okay. It was a plus. This says difference. This does not fit the pattern. You can't do this one. Can't do it. Why not? It doesn't fit the pattern. If it doesn't fit, it doesn't do it. It's just not right. Can't do it. Okay? Does not fit the rule. All right, so what about x to the 4th minus 81? Well, I've got the minus. I didn't realize I had to look so closely for the minus, but I do. And I know this is 9 to the second. So I'm looking at x to the 4th minus 9 to the second. But do I do 4? Yes. Split it in half. Do it this way. So you took the x to the 2 and did 1 and 1. And we're going to do the 4 and do 2 and 2. And so now we have 3. No, we have 9. And 9. Do minus and plus. But looky, looky. That's in the same pattern. We get to go again. We get to go again. That's the answer there.